The two examples that we're going to be going through next are a little bit trickier. The implicit differentiation itself is not going to be tricky, but the setting up and the determining the equation is going to be a lot harder in these two examples. So example 4 says, ship B is sailing south at 16 kilometers per hour. It is 36 kilometers north of ship A, which is sailing east at 12 kilometers per hour. At what rate are the two ships approaching each other or separating after 30 minutes? So to start off this question, I'm going to be drawing my diagram like always, and I'm going to be setting up my knowns or my unknowns. So here I have ship B. I'm just going to say SB, and ship A. Now, I know that ship B is 36 kilometers north of ship A. Ship A is sailing east, so I'm going to draw this arrow in here. Ship B is sailing south, so I'm going to draw that arrow there. I'm going to label this B because that's the path that ship B is traveling. I'm going to label this A. Ship A is traveling this path, and I'm just going to label this one C because we have a Pythagorean theorem, and that just makes sense. So some information that I'm given dB by dt. So I know that ship B is sailing 16 kilometers per hour south. So I'm going to write this as a negative 16 kilometers per hour. I'm also given ship A's speed. So ship A is speed. So dA by dt is equal to 12 kilometers per hour. Since it's going east, I am just I'm just going to assume positive. Ship C, not ship C, there's no ship C. C here, dC by dt is what I'm looking for. Now, I haven't used some of this information, so I haven't used the 30 minutes and I haven't used this 36 kilometers yet. So I'm going to think a little bit about what I'm given. I'm given ship B is going 16 kilometers per hour, and so I know that in the 30 minutes or the half an hour, it would have traveled 8 kilometers. So ship B was 36 kilometers north of ship A, but if it traveled 8 kilometers, then I know now it's only 28 kilometers away. So I'm just going to draw another diagram here just so you can see what's going on in terms of kilometers. Ship A is going 12 kilometers per hour, and so that means that in the 30 minutes it will have traveled 6 kilometers. Now at this point, I can go ahead and start writing my Pythagorean theorem again. So c squared is equal to a squared plus b squared. So now I can go ahead and plug this in. So c squared is equal to 6 squared plus 28 squared. And I'm going to get a value of 28.63 kilometers. So now I know that this distance right here is 28.63 kilometers. So just like the last example on the last video, our formula that relates everything is still just our Pythagorean theorem. The major difference with this question is that all three sides are moving. So when we looked at that ladder question, that hypotenuse or that ladder was always a set length, and so we were able to plug that value in, and this time we're not able to do that. So I'm going to go ahead and derive. So 2a dA by dt plus 2b dB by dt equals to c dC by dt. I have my dB by dt and my dA by dt. I have my b, I have my a, this should be my b, and I have my c, so I really have everything that I need, so I can go ahead and just start plugging this in. So 2 times 6 times 12 plus 2 times 28 times negative 16 is equal to 2 times 28.63 dc by dt. So if I go ahead and isolate this, dc by dt is going to be equal to negative 13.15 kilometers per hour. Now, since this is a negative number, the distance between these two ships is decreasing, so they're actually getting closer to each other, so therefore they're going to be approaching each other. At 13.15 kilometers per hour.